a top-secret aviation program.
They will neither confirm nor deny the existence of records
Funded by a mysterious money trail.
There was a lot of thought into how we're going to hide the various pots of money.
Could revolutionize flight.
Do you think that you'll see manned hypersonic flight in your lifetime?
Oh, yeah.
And unleash a new lethal technology.
Extremely high speeds, Mach 5, 6. That would make these cruise missiles almost impossible to defend against.
098 firm, we have splash. Stand by for PDA.
Every year, more than $90 billion is allocated to clandestine government programs, collectively called the Black Budget. Each individual operation is a black file.
I'm Mike Baker. As a covert CIA operations officer for over a decade and a half,
I supervised missions around the globe. My security clearances gave me access to many classified projects. Now, I'm following the money trail to the secrets hidden inside the Black Files. Los Angeles, 1991. The skies over Southern California are rattled by a series of sonic booms so strong they trip sensors at the U.S. Geological Survey. The booms are followed by multiple reports of unusual contrails, bizarre radio transmissions, and an incredible sighting of a mysterious craft.
in 1990, a year before the sonic booms, an aviation journalist studying a 1985 Department of Defense budget comes across an unusual line item. $455 million earmarked for a black aircraft production called Project Aurora. Rumors and speculation are rampant. Is Aurora connected to whatever caused the sonic booms? A classified aviation project? A top secret weapons system? Or something else? I'm headed to Palmdale, California, outside of Los Angeles. There, sightings, sonic booms, and mysterious craft are part of the culture, in no small part because it's home to Lockheed Martin's top secret aircraft facility known as the Skunk Works.
I'm meeting with Guy Norris, the multi-award-winning senior editor for Aviation Week, known for having sources deep within the U.S. military. Guy has first-hand experience with the sonic booms and Project Aurora.
Guy.
Mike.
Hey, listen, thank you very much for coming out here to meet.
Yeah.
I understand that there's a personal experience that happened that furthered the investigative effort.
Yes, absolutely. In October of '91, this almighty boom shook me out of bed at just after 6 o'clock in the morning. I ran to the window expecting to see a car crash or something on the street right outside, and there was nothing, and it was literally a skyquake. That's how it was described.
That skyquake was the first of a series of sonic booms to strike Southern California. Over the next 16 months, there were 6 more. They were the subject of scientific study, media coverage, and speculation linking them to Aurora. Then came an incredible and credible eyewitness account.
There was an important sighting that was made by a Scottish engineer, Chris Gibson. He was a member of the Royal Observer Corps, which is specifically trained to help sort of defend the skies and to spot aircraft. So what he saw was quite remarkable. I mean, given this, he was a trained observer. I'll show you here. It indicates that we're looking at 2 F-111s, a KC-135 tanker, which of course
refueling.
For refueling, a regular site. But mysteriously, right in line astern behind this tanker was this strange, sharply deltoed, sort of isosceles triangle-shaped vehicle.
Following the sighting came a revealing scientific study.
But further analysis by a NASA specialist in this, Don Megliani, really indicated that we were looking at something that was passing through the skies of Southern California at between speeds of Mach 4 and 5.2 at over 90,000 feet.
My understanding is, at that point, you start going into hypersonic range.
That's right. The generally agreed definition of hypersonic is anything at above Mach 5. So, pretty incredible speed for, particularly for that time.
Hypersonics is the new frontier of speed. anything exceeding 3,836 miles per hour. Still in its infancy, the engineering, technology, and challenges are complex. But the potential to travel tremendous distances significantly faster would be life-altering.
What do you think of the idea that perhaps it's a hypersonic aircraft that's been developed or was in the process of being developed?
The problem with that is that the technology for such a platform, as far as we know, is even now not mature.
That presents quite a mystery. We have proof that something was flying at hypersonic speed, but the technology, at least as far as we know, did not exist.
Gibson and Magliari offer hard and unchallenged data from reliable sources. Are they enough to conclude that Aurora is a top-secret advanced aviation platform? Well, that's one of the questions I'm going to ask an investigator who spent his career digging into Black Files, including Aurora. John.
Hey, Mike. It's good to see you.
See you too. This is very perplexing.
Yes. I asked the Air Force for everything, and they gave me what's called a GLOMAR response, which means they will neither confirm nor deny the existence of records pertaining to the Aurora. This program element ID number allows me as an investigator to go after it under the FOIA and say, I know the program exists, here's the program element ID number, and here's black and white proof it exists.
So what did you find out?
One particular memorandum that was sent through the Pentagon, in the first paragraph, they say that they didn't find any records. Number 2 says, this is a special access program. Access will be granted on a strict need-to-know basis only. What does that tell you? The program exists and it's highly classified.
Right.
That means item number 1 can't be true.
No, they've contradicted themselves.
That's right.
In the same
all
document.
in the same document.
Right.
In my opinion, Aurora or an Aurora-like project absolutely was implemented, built, and is probably flying today.
If John is correct, what kind of craft has emerged from the one first associated with Aurora some 30 years ago? We know it was capable of speeds unheard of at the time. What could a craft capable of such speeds be used for? To get some answers, I'm meeting with an expert on classified aircraft. I'm hoping he'll help me uncover clues from prior Black File aviation projects.
How are you?
That will help me understand the current one.
I'm investigating Project Aurora.
Well, it falls under the black budget. Back in 1986, portions of that, with the name Aurora, for example, had dollar amounts. Because Aurora, the name, was next to other strategic programs like strategic reconnaissance, they assumed that this was another strategic reconnaissance aircraft.
Recon, or reconnaissance craft, are military spy planes whose purpose is to gather intelligence from the air. Speed is key. Is Aurora a modern-day spy craft?
How does it fit in when we talk about some of these other reconnaissance aircraft?
You talk about some of the early black projects, like the U-2. The CIA created a funding channel called Project Shoehorn, and that was used to procure goods and services from unwitting vendors who weren't cleared for the program.
So there was a lot of thought into how we're going to hide the various pots of money.
My old outfit was big into spy planes funded through the black budget. Their crown jewel was the A-12, another Skunk Works design. Codenamed Oxcart, it topped out at Mach 3, or 2,300 miles per hour.
I mean, is manned reconnaissance flights, I mean, is that sort of a thing of the past at this point with what we've got from satellite technology?
The only problem with a satellite is the enemy knows where it is. It's bound by the laws of orbital mechanics. An aircraft, you can fly in from any direction at any time and make a surprise run.
What about hypersonic aircraft? What about the capabilities of that and what that may mean to future developments?
Hypersonics would be a great way to go for airborne reconnaissance.
All these spy planes we've talked about were developed at Skunk Works, all with black budget funds. Each appears to be another step towards attaining hypersonic speed, Mach 5 times the speed of sound. Maybe Aurora is a code name not for just one craft, but for funding increasingly advanced aviation.
One person who should know is a former head of aviation black budgets, and one of the few men who knows what it's like to fly the most advanced reconnaissance aircraft ever developed. I'm on my way to see him now.
I'm pursuing a theory supported by several sources that the Aurora Black File didn't encompass a single project, but instead several top-secret reconnaissance craft, all working towards breaking the manned hypersonic barrier.
Inside the Marchfield Air Museum in Riverside, California, are some of the most top-secret, record-breaking aircraft in American history. This is where I get to talk spy to spy with elite U.S. Air Force pilot Colonel Buzz Carpenter. Now, Buzz has over 60 operational missions flown in the legendary SR-71 Blackbird.
The Blackbird is a Black Project spycraft that holds the world record for an air-breathing manned plane, Mach 3.3, or 2,200 miles per hour.
Colonel,
Well, welcome. Mike, to have you here.
pleasure to meet you, sir. Over 60 missions in the Blackbird.
That's correct. I accrued about 777 hours and got the privilege to fly this airplane over 200 times.
I know something about spying, and I know you can't talk about a lot here, but how important was the Blackbird in terms of the collection of intelligence?
6 presidents used this during crisis situations because they knew when they sent us out, we could keep our track within about 300 feet of what they had designated. We could collect multiple forms of intelligence, and we always came back.
Made of a lightweight titanium alloy, the Blackbird features specially designed surfaces and a radar-absorbing paint to create a minimal signature.
You see here how small the cockpit is. The faster you went in the airplane, the more sensitive the airplane became. 3.2 was our normal top speed, but if you felt threatened, you were fully authorized to accelerate to 3.3.
That's 2,500 miles per hour. Fast, but shy of the hypersonic threshold of 3,800 miles per hour. As a black budget manager, was Buzz aware of Project Aurora and the push for hypersonic flight?
Colonel, you ran the black budget for Blackbird 117 B2. Project Aurora, what can you tell me about that?
Project Aurora is very interesting. We were developing the B2, and the B2 was going to be $32 billion in investment, and another $32 billion to build 132 bombers. When you have numbers that big, to try to hide them in the Air Force budget became increasingly difficult. So I created, and was approved by the Chief of Staff of the Air Force, Aurora. Aurora looked like a reconnaissance program, but in fact it was a lot of the production money that was to be used for the B2. And you put it in the line, and very shortly, Aviation Week and these others said, oh, look, there's a new reconnaissance program, Aurora. It must be the replacement to the SR-71. Worked perfectly. They weren't looking at the bomber.
Do you think that there's a black budget currently that oversees the development of hypersonics?
I most certainly do, because I think you're starting to see things emerge, which is very common with black budgets. They get to a point when they get to a size and they say, well, we kind of got to tell them we're working on it. So sometimes you take it from being black to what we call gray. You protect the most secret part that you want to protect, but you acknowledge its existence.
So Buzz created Aurora as a diversion and believes there is a current hypersonics black file. What projects are being funded by that black file, and how close are we to attaining a functioning platform?
Now, I'm no rocket scientist, so to learn more about this black budget funded technology, I'm going to turn to one of the smartest people I know, Ben McGee. Ben, you know, I've been digging into Project Aurora, right?
Yes.
Which seems to be the U.S. government's efforts related to manned hypersonic aircraft.
Gotcha.
Which seems to be incredibly difficult to do.
Well, yeah.
And I'm wondering why.
There's a real difference between, it's not semantic to say supersonic and then hypersonic. Hypersonic is many, many times the speed of sound. Now, the only things that we have that do that, we're talking rockets, one research aircraft that's gotten that far, that fast. And spacecraft reach that when you're leaving the atmosphere and then when you come back. But flying through the atmosphere that fast is difficult because of the physics. So what happens when you travel many, many times the speed of sound is you've got shock waves interacting with the atmosphere that are compromising not only your ability to keep generating lift, but they're also compromising the integrity of the aircraft. And then you're hitting the atmosphere so hard that it superheats the air around the aircraft itself, just the act of striking it. We're not talking friction anymore, we're talking compression. So it superheats, it would melt most aircraft that we actually, out of normal materials we'd make an aircraft out of.
So you're talking materials, you're talking heat, you're talking stability issues?
Yeah, everything. I mean, you've just described flight. Okay, yeah. So yes, everything about getting something to fly that fast through the air is different and difficult. But this is a very abstract way to describe it, so let me
you probably judge that from the glassy look in my eye. But,
yes, I've noticed.
Yeah, you always have a way to explain things.
Yeah, well, I've got an idea that I can, instead of just telling you what I mean, I could show you. So why don't you meet me here, and I'll show you what I mean, okay?
Okay. You realize that I wanted to talk to you about hypersonics, not trucks.
I tried to get you into NASA's hypersonic tunnel facility at Plumbrook Research Station.
Okay.
And I couldn't, so I brought you to the next best thing.
A truck.
Not just any truck, a diesel truck. Huh?
Yeah. Okay, just to remind you, we're talking hypersonic aircraft.
Yes.
Right? This is a diesel truck.
Yes.
Okay.
Okay.
Marry the two.
All right. Well, all right. Let me turn this thing off. All right. So I haven't lost my mind. There's a specific reason I brought you to a diesel truck, and the reason is how the fuel is lit inside the combustion chamber. Did you know that diesel engines don't use spark plugs to light the fuel?
No, actually, I'm embarrassed to admit I'm of a certain age and I did not know that.
Okay, well, I didn't either. I did a little research. You know what they use instead?
Don't tell me right away. Rocket fuel?
All right, no, that's not bad. No, they use compression heating. It's the very same physical process that hypersonic aircraft have to face when they're flying in the air. So what happens in a diesel engine is the piston in the cylinder crushes the air itself so hard that the air heats up to the ignition point of the fuel. So it uses the physics of squeezing the air, and it gets hot in response, so hot that it literally fires this engine.
Really?
Yeah.
Diesel motors, that's how they operate.
Yeah, it's cool. They burn at a much higher temperature. That's why the engines are made of ceramic. It's able to withstand a much higher temperature. And how does that connect to hypersonics?
How does that connect to hypersonics?
Imagine the piston is the aircraft, and the air is what the hypersonic aircraft is smashing into. And it hits the air so hard, the air heats up in exactly the same way. But the hypersonic problem is the same problem faced by the old space shuttle. It's not friction, it's smashing, it's compressing the air so hard. And that's why the shuttle's heat tiles were also made of ceramic, just like a diesel engine, because it's the same problem.
A hypersonic engine is much more complicated. It's called a scramjet and has no moving parts, meaning no turbine and no compressor. Supersonic oxygen is compressed, mixed with hydrogen fuel, injected into a combustion chamber, and then exhausted through a nozzle, producing thrust. Here you are, you're talking about old technology, right, for a diesel engine. Now you're talking about how that relates to hypersonic aircraft. How far away are we from this?
I'd say we're about at Wright Brothers level. So we've tested devices that are tickling the territory. And I think, if we just keep pushing the bar, much in the same way that we've refined the old diesel engine, we can end up refining hypersonic design and get there.
That's outstanding. The Aurora Black File funded premier aviation platforms, leading to hypersonic flight. But with the challenges been raised, I wonder if manned hypersonic flight is possible, and if so, what are the risks? I'm going to put those questions to a record-breaking pilot who flew an experimental spacecraft into outer space. The Aurora Black File is connected to sophisticated spy planes that altered history. Now, according to sources like Buzz Carpenter, the black budget is funding hypersonics, craft that can reach nearly 4,000 miles per hour.
But what are the risks to a pilot in such a craft? I'm going to find out by speaking to a record-breaking pilot who definitely has the right stuff.
Mike Melville is a multi-world record-breaking pilot. In June 2004, he flew Burt Rutan's experimental Spaceship One past the edge of space, becoming the first commercial astronaut.
Well, Mike, thank you, first of all, for the time. It makes sense that a space legend has his own museum. And this is a fantastic place. Now, you ran a lot of tests, but the first official flight that you did with Spaceship One, what was that like as you were getting ready to take off? What about the unknowns?
It was pretty scary, frankly, you know. I mean, I really didn't know if it would fly the way Burt said it would, but it did. And, you know, my first words out of my mouth after I dropped off and pushed the controls and wiggled them, I said, "It flies great, we're in good shape." And from there on, I went into a straight down dive, went to as fast as I could go straight down, and then I put 6 Gs on the airplane to make sure the wing would hold together.
Okay, now I know that's what a test pilot does, but talk to me about the mentality of saying, now I'm going to put it in as steep a dive as I can, and then come back to see if the wings hold together.
Well, that was on the cards, you know. We discuss what we're going to do in flight. It's all typed out, and I do each step of it regardless of what happens. You know, a test pilot sometimes doesn't make it. Fortunately for me, I made it every single time.
Powered by hybrid rocket motors, Spaceship One reached Mach 3.4, or 2,600 miles per hour, faster than the SR-71 Blackbird and edging closer to hypersonic speed. It was Mike's first time flying that fast, and his first time experiencing the effects of high-speed flight.
What your body's doing, what it feels like.
Well, first of all, there's a lot of thrust on your body. You know, you're looking at 3 or 4 Gs, you know, which is 4 times my weight. So I weighed over 1,000 pounds. That was a horrible feeling for me. You get a little tunnel vision because of the G forces, pulling the blood away from your eyes. And you can't talk, you can't breathe. You're really struggling with it.
And also you're trying to maintain control.
And you're trying to fly the airplane as well.
Flying near hypersonic speed also places extreme stress on the craft. Any unexpected or sudden movement can threaten both the vehicle and the pilot.
Yeah, on the second flight to space, at very high speed, 2.65 or 2.7 Mach, the airplane suddenly did a snap roll, which is a very fast, very ugly maneuver that really shakes up your body. But it continued to do that for 29 rolls until I got outside the atmosphere. When I got outside the atmosphere, I could fix it with the reaction control system that's built into the plane.
What was that doing to your body? What was that doing in terms of your control, your ability to stay conscious?
All I could do was just stare at the airspeed indicator and hope that I just didn't get seasick or something. But I don't know, I lucked out. You got to be doing things quickly. No, you know, back then I was a lot younger. I was only 63, I think, or 64.
Oh, only 63?
Yeah.
Okay. With the technologies that are developing now, and based on all of your experience, do you think that you'll see manned hypersonic flight in your lifetime?
Oh, yeah. No question about it.
You do?
Oh, yeah. Oh, yeah. There's no doubt about that. I mean...
Would you like to be behind the stick on those?
I really would. but at 78, 79 years old, it's a bit too late.
Mike's experiences are both a profile in courage and a cautionary tale. Having black budget funds to push us to or beyond our limits of technology is a dangerous pursuit. I'm curious to get even a small taste of what those limits are. I've reached out to a military pilot who's agreed to take me beyond the normal parameters of flight.
Earl.
Mike, how you doing?
I'm doing good, thanks, man. I'm doing very well, thank you.
Thanks for coming out to fly with me.
Well, you know, we had that chance to talk on the phone, and so, you know, I've been digging into Black Files related to hypersonic flight. And right now, I've been trying to understand the impact on the human body, right, from high-speed flying. What does that mean? Right? And what does it mean for the aircraft as well?
The real challenges with manned hypersonic flight is if you introduce any kind of maneuvering. And today what we're going to do is we'll use this old technology of biplane. We're at the low end of the spectrum. We're not very fast. but we're very maneuverable, and that'll give us a taste of some of the challenges if you talk about maneuvering manned hypersonic flight.
Okay, well, before I climb into this puppy, what should I know about that? About hitting 5 or 6 Gs in terms of the impact on the body?
Well, if I pass out, you can fly us back.
Oh, good, sure.
That shouldn't be a problem.
Okay.
What you might feel is a little bit of dizziness as the blood drains out of your head. And in the worst case, maybe just a little bit of loss of vision as you lose your peripheral vision, because that part of your eye is very susceptible to blood loss.
Okay.
1 G is the force of Earth's gravity, your normal weight. Hypersonic flight imposes more than 10 Gs on the human body, 10 times your weight, forcing blood away from the brain, which can be fatal. Earl spent nearly 30 years in the Marine Corps flying F-4s, F-5s, and F-18s. He retired as a colonel and has logged thousands of flight hours. I'm in good hands with him at the stick.
So we're good to go.
Good to go.
Oh.
All right.
Earl's promised not to take me beyond 5 or 6 Gs, a fraction of the forces that would be felt in a hypersonic craft, but a lot more than I've ever experienced. Well, here goes nothing. Every one of the journalists, military pilots, and other experts I've spoken with agree that the Black File Project Aurora has evolved into a quest for a hypersonic craft. Now, I'm taking a flight of my own to better understand the dangers of high-speed flight.
Okay, I think everything's connected. You ready to go?
Good to go.
Victor's 1, clear for takeoff 28 left, straight up.
Hold on, quick.
All right, here we go.
Digging into the Black File on hypersonic flight, it seems pretty clear that the holy grail is really manned hypersonic flight. Talk to me about why that's so difficult to achieve.
Well, as you can see here, we're flying along at about 110 miles an hour at about 1,500 feet. You can feel the forces, the aerodynamic forces from this open cockpit biplane. Now, if you imagine if we were going 4,000 miles an hour, the aerodynamic forces that are on the airplane, and that translates into the challenges for maneuvering manned hypersonic flight. It's okay if you're just going to do a straight line, but if you want to do any turning at all, then the amount of G's required is pretty significant. At that airspeed, actually you go so fast that you get to the point where the molecules begin to disassociate.
At hypersonic speed, the air molecules around a craft break apart or dissociate, and/or pick up an electrical charge or ionize, creating a barrier between the airplane and the atmosphere. This produces enormous stress and friction, requiring complex engineering and design.
What does it mean for the impact on the human body, on the pilot?
As you increase the G, obviously you can increase the maneuvering performance, but after about 8 Gs, you start to approach the tolerances of human beings. All right, so we're just going to do some mild maneuvering here just to kind of give you an idea. I'm going to do a level turn. We'll probably hit about 2.5 to 3 Gs. So here's a little bit of a taste of what the G requirements will be. So here goes a hard turn left. That was about 2.5 to 3. All right, we'll do one aileron roll, just so you can say you did it. Let's climb one up. Here we go. Ready? 1, 2, 3.
Yeah!
How you feeling up front?
Yeah, really good. This is fantastic. The feasibility of manned hypersonic aircraft at some point in our future. What do you think?
I think that there's a great chance that both of us we'll see some sort of application of manned hypersonic flight in our lifetime.
If Earl and my other sources are right, that a manned hypersonic craft is in our future, what platforms are currently in development? Well, there's one place that should know. The same place where the U-2, A-12, and SR-71 Blackbird were all conceived, designed, and engineered. I'm on my way to Skunk Works, the super-secretive facility of Lockheed Martin. Within that compound, a generation of Black File aviation projects took wing.
They're widely believed to be working on the next generation Blackbird, the SR-72. It's reportedly able to fly at 6 times the speed of sound, or 4,000 miles an hour. Now, I did my best to gain access to the facility, but no luck. Fortunately, I've managed the next best thing. I've secured a meeting with the Skunk Works' former director of advanced systems development. Any chance he'll reveal information about the Black File dedicated to hypersonics? Well, I'm about to find out. The hunt for Project Aurora has led me to conclude that while the SR-71 is the last supersonic manned plane known to have flown safely, it's not going to be the last. There are black budget projects currently working on hypersonic craft and possibly other applications of this incredible technology.
Recently, Lockheed Martin announced its plan to develop a successor to the SR-71 Blackbird, the SR-72, purported to reach Mach 6.
I'm about to meet with the former Aerospace Division Director of the super-secret company behind the SR-72, Lockheed's Skunk Works. I'm going to ask him about what I and others believe Project Aurora has morphed into, a hypersonic aircraft. Steve, you are a director at the secretive Skunk Works.
Right.
What is the Skunk Works?
The Skunk Works is a division of the Lockheed Martin Corporation that is tasked with, quite honestly, creating breakthroughs.
What's it like to be inside there, working with those folks?
I couldn't tell my wife what I did. I couldn't tell anybody what I did unless they were briefed on the program.
The follow-on from the SR-71, there's been talk of the SR-72. To what degree has that been developed? Is it already operational? I mean, where are we with that?
The Skunk Works doesn't talk very much about the SR-72.
Is there a black budget that exists to help fund that process?
I'm not going to discuss black budgets or any of the unacknowledged stuff that goes on in the classified world.
Even so, given Steve's insights into aviation and the Skunk Works, I wonder if he believes a hypersonic platform is possible.
That's a lot to ask from an airplane. Going hypersonic, 6 times the speed of sound, is a very, very difficult thing to do. I mean, the Blackbird going Mach 3 was a very tough thing to do. And going twice that speed squares the challenges that you have. It's not double the challenges. I never say something's impossible. And one of the things that I treasured about working at the Skunk Works is you just assumed something could be done. If they were given a challenge, you assumed it could be done, and you figured out how to go do it.
Do you think that the U.S. is currently leading the way in terms of research for hypersonic craft?
The U.S. certainly is starting to invest very heavy in hypersonic. I mean, you see Russia and China investing very heavily in hypersonics as well. So right now, it's a race.
Mm-hmm. Would Skunk Works be heavily involved in that race?
Skunk Works is heavily involved in that race right now. They are working a couple of the programs.
Just between you and me, we're not going to show this to anybody, but can you tell me about those programs?
No.
Speaking with contacts at the Department of Defense, I've determined that the race Steve referenced is not for manned hypersonic craft, but for unmanned hypersonic missiles. The hypersonic Black File is a modern-day arms race. I'm at the headquarters of one of the most respected global think tanks in the world, RAND Corporation in Santa Monica, California. RAND was created just after World War II by the Douglas Aircraft Company with the goal of providing nonpartisan research and analysis to the military. These folks, they possess decades of institutional knowledge, declassified information, and cutting-edge technology. And they're keenly following the developments of hypersonic craft. George, thank you very much, first of all, for taking the time.
Oh, really thank you for taking time to talk to me.
Hypersonic capability, what are we talking about?
We're talking about 2 types of missiles. We're talking about what's called an hypersonic glide vehicle, which is unpowered, it's a glide vehicle, and also hypersonic cruise missiles, which are cruise missiles as we know them, but they go much, much faster. They go what's called hypersonic, at hypersonic speeds. Extremely high speeds, Mach 5, 6, or even 10 or so. And that would make these cruise missiles very destructive and almost impossible to defend against.
Hypersonic cruise missiles are powered by scramjets, a highly advanced propulsion system that mixes compressed incoming supersonic oxygen with hydrogen. Hypersonic glide vehicles, or HGVs, are placed on rockets, launched, and then glide on top of the atmosphere. They're about 5 to 10 feet in length, weigh about 500 pounds, and are encased in materials like ceramic, carbon fiber composites, or nickel-chromium superalloys. Traveling at about a mile a second, the Russians could allegedly hit the Pentagon from a launch near Bermuda in 5 minutes.
Do we have missile defense systems currently in the United States that are capable of defending against hypersonic missiles or hypersonic glide vehicles?
No, we don't. We don't really have any because our current system is designed to defend against ballistic missiles.
Well, that's not a particularly comforting thought. When we talk about hypersonic missiles, are we talking about putting a traditional payload on there for delivery?
So actually, a hypersonic missile is going so fast and is so accurate that you don't need to put any explosives on it. The energy, the kinetic energy within the vehicle, there's so much of it, it's flying so fast, then when it hits its target and it hits it accurately, it can cause a lot of damage.
The missile's kinetic energy at the time of impact makes them powerful enough to penetrate any building material or armored plating with a force of 3 to 4 tons of TNT. Until recently, the Defense Department's total hypersonics budget was $100 million. Now, with a new focus on hypersonic missiles, it's $2.6 billion and projected to go up to $5 billion annually, making it one of the most expensive Black File programs.
Hypersonic missiles ready to fire in a few short years. And it all started with the Aurora Black File. Are we on the cusp of a new nuclear storm? Or is there a different way forward? Imagine an enemy deciding to attack from, say, 1,000 miles away. Now imagine you've got 5 minutes or less to react. And you may not even see the missiles approach. That's the threat posed by hypersonic weapons. That's the threat we're facing, possibly in the immediate future.
According to George Nacuzzi, the U.S. currently does not have a defense to this scenario. But if I know anything about the government, there is a plan. It's just hidden in the black budget.
Patrick.
Hey.
Hey, how you doing?
Good, Mike. How are you?
I'm doing well. Patrick, talk to me about what the U.S. may be doing currently to develop some defensive systems against hypersonic weapons.
The first big plan is for what's called a space sensor layer. This is going to be 6 different layers of satellites. You're going to have satellites that are highly maneuverable to track new types of missile threats, including hypersonic missiles. Weapons capable of traveling 5 times the speed of sound, so you can't launch an interceptor to destroy them in mid-flight. This is what these satellites are going to do. They're going to track the maneuverability of that hypersonic weapon to potentially allow a different set of missiles, or perhaps a jet that is armed with a cruise missile or something else, to hit that hypersonic weapon before it hits its target. But to do that, you have to know where that hypersonic missile is at all times, and that's what that space sensor layer will do.
From your research, how far along is the U.S. government in developing that defensive capability against hypersonic missiles?
Well, we're moving ahead with the launch of a first layer of that space sensor layer, and there's a lot of investment going into putting that layer into space as quickly as possible. But right now, all of that is capable of doing is watching the missile. So actually intercepting it, that's going to be a much bigger challenge. So some of the potential techniques that the U.S. military might deploy to actually stop that missile includes placing weapons, possibly lasers or other types of missiles, on planes to hit it, or potentially placing lasers or other weapons on satellites to hit it from above.
Some of these plans sound exactly like those of another black budget-funded series of projects, the ones for Space Force. Is the government preparing for hypersonic missiles to be a big part of any future conflict in space? And if so, could manned hypersonic craft be a part of that as well?
Okay, in all your work, all your investigative efforts, sir, have you seen anything that tells you that Project Aurora still is in operation, still exists today?
No, but at the same time, we do know that the Pentagon is interested in developing manned hypersonic flight in the year 2040.
Do you think they're ahead of that timeline and they're just reporting this because that's what the government does in terms of timelines?
Well, when they originally made those statements in 2016, the only thing that's changed in our hypersonic missile development program is that it is accelerated.
Patrick, what would the purpose be for manned hypersonic aircraft? Why this interest and why all this effort over the past few years in current times to develop?
Well, think back to the D-Day invasion of Normandy. You had a ton of unpredictability about when it might be possible to put a handful of Marines on a beach. Months of planning went into it. It was in jeopardy up until the moment it was actually launched. Now think about what a hypersonic plane would allow you to do. You could load up a team of SEALs from Bahrain, potentially in Africa, potentially out of Germany, put them on a craft, and then put them behind enemy lines at any point that you chose, almost instantaneously within minutes, basically. So what it allows you to do is invade, essentially, your adversarial country in a way that can't be detected or defeated.
The Aurora Black File began as a rumor of an amazing craft with incredible capabilities. Today it's morphed into a hypersonics program that I believe the U.S. government will continue to develop deep within black budgets and top secret programs, as well as in plain sight. This Cold War 2.0 is escalating at hypersonic pace. We have to push the boundaries of technology in order to own the high ground in this era of competition, power, and survival.